Hello, hope you're well. I'm going to try to talk a little bit about science today. Um, Magic numbers. Um, you open a physics book up, you look up magic numbers, a chemistry book up, open a chemistry book up and look up magic numbers, they're there. Why are they there? They're there because they have no explanation why they're needed. They're needed because the foundation of their theories are incorrect. that because they're incorrect, they have to have magic numbers. And there's no explanation for the magic numbers. At least they have none. It's possible that I can shed some light on that. I made a misstatement in the last video. Little technical problem here. Sorry, guys. Let's see, a little blurry. I mentioned that in the last video, I mentioned we were talking about this chart, and I mentioned the 4 pillars set before time. That's only partly correct, in my belief, my opinion. So I'm going to take the pillars off of here. What do I do? What do I believe about the 4 pillars set before time? That we would have to refer back to another chart that we had up here that showed time being, linear time being in these spheres that extend outward that are connected. Linear time would be what was made possible during that part of creation. Prior to there being matter, there was no way to measure from one point to another. So, in my thinking, that linear time was created when matter was created. That prior to matter, there was some sort of time. Something we might not be able to comprehend. So, and I talked about the genius of this chart here. This is the origins. We don't know how old they are, but I said that there was some genius in this, the way it was set up. And you won't be able to see them there, but I've put up here south, north, west, and east. These are the 4 pillars, if you will. And I put south up here because the magnet always points north. And I also suggested that if you were going to take elements and create molecules, that you could take from this side of the chart and mix with this side of the chart, and that those would make stable elements. Mostly right as well, but there's also this chain down here that's down the center that they can also mix with, create very stable elements, or stable molecules. And then, of course, these are the stablest, the noble. And although these numbers, 2, 10, 18, 36, 54, 86, and 118 aren't in the magic numbers, they are known. They also refer to these magic numbers as IBE, incredible bonding effects, IBE. There's also 6 and 14, but these magic numbers are 2, 8, 20, 28, 50, 126, and include 6 and 4. What are 6 and 4? Carbon, Silicon. We are a carbon-based life form. We think of carbon as being the most, in silica, being the most sticky, it receives the most, it has the most connections, it has the most bonding potential. I would disagree and say that it's hydrogen that is actually the most connective, but that's just me. All right, so let's talk about bonding. Let's talk about combining elements to make molecules. See if you can see that. If you can see that. Anybody joining me there? Hi, Scotty boy. Hope you're well. Can you see this board at all? Is it all shiny and blocked out? Let me know. We'll talk about some common molecules. Take two elements from this chart, put them together. First one I'll talk about is H2O, water. One oxygen, two hydrogens. And then I totaled them here and they came up with 10. Well, 10 isn't on our magic numbers here, but it is. It is neon, number 10. It's very stable, not easily separated once you put them together. How do you create it? Well, you take a certain amount of hydrogen and a certain amount of oxygen, and you put a little spark to it. Boom! So it's a very violent thing to put them together in that way. We'll talk about anion, cation structures, and here's yet another molecule that we're going to combine here. Na, sodium, and Ci, chlorine. And when we combine those two together, we get 28. Is that a magic number? It is. It is. And this is an anion cation structure. What is that? They have an incredible bonding effect. Very strong bond. Now, if we came over here to our chart of elements, we would see. Oh, maybe I think I might have made a note here. Let's see. So I don't have to be hunting too much here. Okay, 11 west. So I'm looking for 11. It's on the west side. That is sodium, Na11. Okay, it combines with Ci. Here on the east, we have chlorine, 17 east. So what I was suggesting was when these two come together, they're directly opposite each other. They also total a magic number, which I'm not sure that they're aware of, but they probably are. A very stable bond. We mix these two together, we get salt water. We'll talk a little bit more about that combination when we get to nature and gravity and examples of anti-gravity in nature. I've got a list here I printed out back in 2008. This is some old work I'm reviewing. I'm a little rusty. But here we have these things on this side of this list are common cations, and on this side are common anions. And what they're doing here is they're giving you like hydrogen with a plus sign. And all of them on this side are plus signs, +1 or +2 or +3. They're assigning an electrical charge to these electrons. Or protons, either one. But no, it would be electrons. Or no, it would be electrons or protons, excuse me. And on this side, the anions are all negatives. Now, in my work, I take all of these pluses and all these minuses, and I turn them into north and south. That in the work I've done, it is all about magnetism. So if we just looked at a few of these, hydrogen C1. Hydrogen's in the center as well. And if we combine it with oxygen over here, so it can go either way with hydrogen, either side of the chart. Sodium, we just talked about sodium. No, we did not. We talked about chlorine. Chloride. Chlorium. No, chloride. Chlorium. Chloride is an acid. Sodium, 11 west. Okay, over here. It can combine easily with anything on the other side. In that case, it was. We did talk about sodium chloride. Potassium. Potassium is, I miswrote the number. I skipped that one. Center, yes. Oh, we'll just bypass potassium until I see it here. Potassium. It would be on the west. It can easily connect to 16 east, which is sulfur, potassium sulfate. So any of these that we look at in this little list of common cation anions, we'll see this correlation where the left or the right or the center is connected. And they connect and make very stable molecules. So in this example, we see that the combination of H2O creates 10, which is in that noble line here. It makes it kind of magical. Not that I needed a magic number. And the same with sodium chloride here. We came up with 28, which was a magic number. And if you look over here, it's 18 to 36, so it doesn't really fit there. We combine these two, we get 38. Well, 36 is the next noble, so we're 2 off from there. So I'm going to try to keep this brief today. I've got a lot to do. We don't need this up here. Talk a little bit about H2O. That is hydrogen, oxygen. This angle here is very particular. It's something like 104 degrees to maybe possibly 109 degrees, that it can vary slightly. What else can we talk about? We can talk about its states, different states of matter. It can be gaseous, it can be liquid, or it can be solid. But that's actually an understatement. It can also be structured. So there may be a fourth state. I suggest there might be a fifth state. If we were to, I will suggest that what we're looking at here is liquid. And then if I redrew this again, and I inverted the hydrogens upwards, and they give all these things charges, where I give these magnetic properties. I take their positives and make them souths, and their negatives and make them north. And I'm suggesting that this one is in its gaseous form. And what would the solid form look like? It would look like this. And they'd all stack up, and they would create a bond, which I call a molecular cohesion. We won't get into molecular cohesion. But now I'm saying that there's actually an inversion that goes on here, What do we know about liquid and gas? What do we know about liquid water and gaseous water? Well, this weighs about 8 pounds per gallon. Wouldn't know the liters, but anyhow. And then when it turns into a gas, it's it loses its mass. The mass goes away. I suggest that the gravity has been turned off, and that what happens next is once the gravity is turned off, not completely, mostly, that we can have other structures attached to it, just like we did when we had ice. So it could be nitrogen, it could be another oxygen, that this weak bond that I talked about could appear. And nitrogen, if we run over here, is number 7. It's a very light gas. Oh, the other thing about the combination of oxygen and 2 hydrogens, this is the lightest gas there is. This is a very light gas as well. But when we combine these two, what happens? We go from light gases to a heavy, viscous liquid. Well, what's up with that? What's up with that is that in combining these two, we've altered the spin rates. And when we alter those spin rates, part of that spin rate is working with what we understand to be gravity. What I'll suggest is actually the magnetosphere of the planet. That the Earth is completely encompassed in this magnetic field. And that when we alter and we combined different elements in a known weight and such, that their specific weight, their gravity is increased or decreased. And in the case of when we take this, which can be any of the 3 states, it goes from a super dense liquid to a different state of matter, and now it's light. And I suggest that nitrogen, being light, can attach to this, and then it can rise up and float away. So, not completely, the gravity isn't completely off. If you boil a pot of water, what happens? The steam comes out and rolls down the side. So the gravity is still there. If we had more nitrogen, and also the other thing about nitrogen and oxygen, we have like maybe 10 to 20%, depending where you're at, of oxygen available in our atmosphere, but we have like 70% of nitrogen. Very, very, the most part of the air we breathe is nitrogen. So let's see, what else did I want to touch on here? Well, over a decade ago, I wanted to know why hot air rised. And it took me 6 hours on the computer to not like any answer. It took me another 6 months to get to how we can have an orbital of an electron jump from in one of these more complicated elements, how it can jump from one to the other automatically. We could talk a lot about, I don't know when we're going to talk about some of these things. I'm running out of time. The other thing to mention about this chart over here, hardly visible. Stability. Well, we've got two in here that form the center. We used to call them energy shells. Now they call them energy levels, I guess. But any of these elements, any of all of these elements have these two elements at the center. And then as we build out to the next layer, we have the very first one is lithium. It's one more of their electrons, one more of my magnetic connectors. So it's one attachment. Then you can argue, if we go back here to their bonding scheme, we have H2O again. I will suggest that oxygen, there's only one electron here in this hydrogen. So once it's bonded to oxygen, you think that these two are closed, but they can still make a link. So there's there one electron, or is that electron doing double duty? Or does this combination allow other things to happen elsewhere? It gets complicated. I'm trying to oversimplify the complicated. But what I'm suggesting is each time you go around here on this, we're calling this the west side, lithium, one more. Beryllium, one more. Boron, one more. We get to carbon, one more. So what we're doing is we're adding attachments. And when we get to carbon, we're up to the maximum, which is 3. Or in my book, 6, but 3. And then when we move further around here to nitrogen, we actually have a position that closes. It goes from where this one was 3 available, now we only have 2, 1, 0. Now we have, I'm going to have to do my own review here. 6, 5, 4, 3, 2, 6, 4, 3, 2, 1, 0. What we're doing is we're subtracting as we go around here. So oxygen only has 2 available, fluorine only has 1, and when we get to the nobles, those attractions are all kept within that element. So that's why they call them noble. That's why they're inert. They neither want to mix with anything else, or you can't add to them, you can't take away from them. That's what this whole line here suggests. We go out to the next level, we do the same thing. And what I'm suggesting is that anything that's beyond the center of this is all of this adding stability and adding a whole bunch of different things that can happen when you start applying energy to it. In my theory, should we talk about that? Let's talk a little bit more about water and salt water, particularly. So we've got a very stable element here, anion, cation molecule that can also mix with H2O. And what does that give us? That gives us salt water. 70% of the oceans are salt water. When we turned off the gravity here in oxygen, that was one example of anti-gravity, if you will, or the absence of gravity. Water, H2O, and NaCa. So salt water, the oceans, our moon. So we have the Earth, we have our moon orbiting around. Sidereally 27 days, synodic. Do we remember 28 from somewhere? Yeah. I told you that the sun turns on its axis every 28 days. It's turning almost the identical rate as to the sun turning on its axis. So if the sun makes one turn, the moon orbits the Earth one time. Now let's talk about tides, because this is another example of gravity being turned off, lessened. Not completely turned off, but lessened. So here we have the moon and the earth, and we have this thing we call gravity. So we got this interaction here between the mass of the moon and the mass of the earth, and we got this planet covered with water. So logically, you would think if the moon is here, then, well, we'll switch colors. I'll wear out my black otherwise. So logically, you would think, hi, glad you made it. I'll look and see comments in just a moment. I'm on a roll here. So logically, you would think that high tide would be somewhere over here, because the moon's pulling on it right here. Well, that would be incorrect. If the moon is here, then high tide would be in a range somewhere over here, 90 degrees from the moon. For high tide, as the Earth is turning, that tide moves in conjunction with it. So if I'm standing here and I look towards the east or the west, because that's the way they're going here, that if the moon is right above my head, and if I look to the east, somewhere over the horizon there, following the curve of the Earth, that's where high tide would be. The same would be true if I look to the west. Somewhere over the horizon there would be high tide. It's not here. And in fact, they'll say if the moon's rising, if I see the moon rising on the east, because it rises in the east, guys, and it sets in the west. So if it's rising in the east or setting in the west, high tide is somewhere close to where I'm at, even if I'm on the ground. So what's going on here? Why the discrepancy? Why this? If the moon's here, high tide is like the moon's about a 6 hour. The moon's orbit is a set rate. It's almost 1 hour plus every day. So 48 to 52 minutes per day. If it rose at well, there's a cycle. Where was I going? Don't recall where I was going. I lost my train of thought. Oh, I was going to explain why this is. Why is this? Well, the moon has a magnetic field as well. We pretend it looks a little like this. The Earth does also. So what's happening here is when these two magnetic fields interact, the moon being where we have our south up here, our north here, because the magnet always points north, south on top. The moon is entirely backwards. So when these two magnetic fields interact, that the structure here that is created in this salt water is made lighter. When it's made lighter, it lifts up a little bit. Not a lot, but a little bit, it lifts up. So we're actually turning gravity off. Now, the other people that tried to come up with a theory to explain this suggested that what was happening here was the gravitational interaction between the moon and the sun was pulling the Earth more than the water, because the Earth is denser material. and then it's pulling it. And when it does, it's leaving the water behind and not pulling it. So that would be why the water rises. I don't think so. So a real little recap is we got magic numbers. We got magic numbers in physics and chemistry and every branch of science. They got magic numbers. Why do we need magic numbers? Because they've made a mistake at the very lowest level, and because they've made a mistake, just like when we start an equation, if we make a mistake in the first line, all the work, all the calculations are dependent on that first line of code, and it all becomes nonsense. So that's what's going on with our with that. So I corrected that. We testing. I better not go there. I want to keep it brief today. Do you remember? Scotty remembers. I'll look at comments in just a moment. Remember I bought a trash can in? We're going to start throwing away things. We're going to create a new language. Okay, hello Jerome. No, looks good. Thank you, Scott. Made it at work. Must have a little break. Yeah, we're running out of time, Scotty. Actually, we're doing very important work. We're doing some ground level work on the Anne Marie will made me enjoy this. 101, I decided the 101 is a reference to balance. That everything is about twos, pairs, if you will. Fourth world into the fifth world. The fifth world being a prime number. The fourth world being divisible by 2. And you can divide that by 2 again. Then you get 1 and a 0 and a 1. How about that? Just balance. Between 4 and 6. And the last part of the definition of cardinal point is a cardinal point is a hinge. Or if you're raised in the Catholic Church, it's a guy that stands at the door. The door is opening. And we're talking about Genesis Revisited. Genesis, humanity's in for a big upgrade here, guys. We're getting there. Previews, hooks. I guess that's it for now, guys. I hope that you have a nice day, and I'm going to go and do something fun, I hope. If not, I'll get something done. So, that works for me, huh, Scotty? Used as a portal. There's plenty of them. And we'll talk about the portals, what was probably brought in. And what we think about as evil could simply be, just as somebody would watch my videos and say, it's totally unstructured, it's insane, it makes me insane to even watch, but there's a possibility that there are life forms out there that resemble the hive, the beehive. I'll have to talk about the ant colony as well, the builders. That any time that they're exposed to lack of structure, they're going to try to put it into structure. What is structure anyway? Well, it's a good question. What are patterns? I've been seeing a lot of patterns. I've had some confirmation on some patterns that I've been keeping an eye on. I haven't had much time to go out to YouTube, but I've seen some patterns that are developing. They will talk about those when we get together next. Have a good day.